Question number 1. The breaking stress for wire of unit area of cross section is called its first option Young's modulus, second option tensile strength, third option weld point, fourth option elastic limit. We know that breaking stress is the maximum force that can be applied on a cross-sectional area of a material in such a way that the material is unable to withstand any additional amount of stress before breaking. Breaking stress may also be known as the ultimate tensile stress or breaking strength. Second option is the correct option. The breaking stress for the wire of a unit area of cross section is called its tensile strength. Question number 2. Longitudinal strain is possible in case of first option gases, second option liquid, third option only solid, fourth option only gases and liquid. We know that solids have definite shape and size and can stretch in length due to the force applied. Thus, longitudinal strain is only possible in solids and not possible in liquid and gases. Third option is the correct option, only solids. The longitudinal strain is possible in the case of solids only, not in case of liquid and gases. Question number 3. For obtaining appreciable extension, the wire must be first option short and thin, second option long and thick, third option long and thin, fourth option short and thick. We know that extension is directly proportional to the length and inversely to the area. For the appreciable extension, length must be long and area less or long and thin wire. Third option is correct. For obtaining appreciable extension, the wire must be long and thin. Question number 4. If the length of a wire is reduced to half, then it can hold the first option same load, second option 1/4 load, third option half load, fourth option double load. We know that breaking force directly proportional to the area of cross section of the wire. That is, load held by the wire does not depend upon the length of the wire. First option is the correct option. If the length of a wire is reduced to half, then it can hold the same load because breaking force does not depend upon the length of the wire. Question number 5. The substance which shows no elastic after effect practically is first option steel, second option rubber, third option copper, fourth option quartz. We know that steel, copper and rubber are known to regain their original shape and size after being deformed within the elastic limit. Quartz is highly elastic in nature as it does not get deformed easily. As a result, quartz has practically no elastic after effect. So fourth option is the correct option. The substances which shows no elastic after effect practically is quartz. Question number 6. The change in the shape of a regular void is due to first option bulk strain, second option shearing strain, third option longitudinal strain, fourth option volume strain. We know that all the strains just extend or contract the measurement of a body except one. Only shearing strain is a type of strain that changes the shape of the body. Second option is the correct option, shearing strain. The change in the shape of a regular body is due to shearing strain. Question number 7. Out of the following material whose elasticity is independent of temperature? First option copper, second option inverse steel, third option brass, fourth option silver. We know that elasticity decreases with temperature for steel, copper and glass. One exception is inward steel, because inward alloy of iron that expand very little when heated. It contains 64% iron and 30% nickel. Inward was formerly used for absolute standard of length measurement and is now used for serving tape and in watches and various other temperature sensitive devices. Second option is the correct option. The material whose elasticity is independent of temperature is inward steel. Question number 8. In magnitude, hydraulic stress is equal to first option hydraulic pressure, second option hydraulic strain, third option hydraulic force, fourth option restoring force. We know that the internal restoring force per unit area in this case is known as hydraulic stress and its magnitude is equal to the hydraulic pressure, that is applied force per unit area. Option first is correct. In magnitude, hydraulic stress is equal to hydraulic pressure. Question number 9. If both the length and radius of wire are double, then how does the magnitude of elasticity change? First option double, second option half, third option become 1/4, fourth option remain unchanged. Explanation. Young's modulus of elasticity is property of material and Young's modulus of elasticity is independent of shape and size of the wire. Value of Young's modulus is unchanged when radius and length of the wire is double given that material is same. Option 4 is correct. Remain unchanged. If both the length and radius of wire are double, then modulus of elasticity does not change because it is independent of the shape and size of the wire. Question number 10. Shearing strain is expressed by first option angle of shear, second option decrease in volume, third option angle of twist, fourth option increase in volume. We know that shearing strain is expressed as the tangent of the angle made to the perpendicular to the area of surface under consideration. The volume or work strain is the change in volume associated with the work pressure or stress on the material. We get that shearing strain is expressed by an angle of shear. Option first is correct option. Shearing strain is expressed by angle of shear. Question number 11. The ratio of the change in dimension at right angle to the applied force to the initial dimension is known as first option Young's modulus, second option Poisson ratio, third option lateral strain, fourth option shearing strain. As we know that the ratio of change in dimension at right angle to the applied force to the initial dimension is lateral strain. So here in this question, option third is the correct option. The ratio of the change in the dimension at right angle to the applied force to the initial dimension is known as the lateral strain. Question number 12. Longitudinal stress depend on first option area, second option length, third option volume, fourth option mass. We know that stress experienced by an object along its length due to the presence of equal and opposite deforming forces perpendicular to the area of the cross section is called longitudinal stress. First option is the correct option. Longitudinal stress depend on area. Question number 13. The work modulus of perfectly rigid body is first option 1, second option infinity, third option 0, fourth option none of the above. We know that for a rigid body the value for the strain is 0. In other words, the rigid body does not produce elongation for any given amount of load. The bulk modulus is in direct relation with the Young's modulus. Hence, bulk modulus for the rigid body is also infinite. Second option is the correct option. The bulk modulus of a perfectly rigid body is infinite, that is infinity. Question number 14. When impurity are added to an elastic substance, its elasticity. First option increases, second option decreases, third option becomes zero, fourth option may increase or decrease. When we add impurity to the elastic substance, its elasticity may be increased or decreased depending upon the impurity that can be added to the elastic substance. So here in this question, option 4 is the correct option. When the impurity are added to an elastic substance, its elasticity may be increased or decrease. Question number 15. When the intermolecular distance increases due to tensile force, then first option, there is no force between the molecules. Second option, there is a repulsive force between the molecules. Third option, there is an attractive force between the molecules. Fourth option, there is a zero resultant force between the molecules. If intermolecular distance increases due to the tensile force, then there is an attractive force between the molecules. So in this question, option 3 is the correct option. When the intermolecular distance increases due to the tensile force, then there is an attractive force between the molecules. Question number 16. Which of the following elastic moduli is used to describe the elastic behavior of object as they respond to the deforming force acting on them? First option, bulk modulus. Second option, shear modulus. Third option, Young's modulus. Fourth option, all of these. We know that bulk modulus, shear modulus, Young's modulus are used to describe the elastic behavior of object as they respond to the deforming forces acting on them. So in this question, fourth option is the correct option. We use bulk modulus, shear modulus, Young's modulus to describe the elastic behavior of object as they respond to the deforming forces acting on them. Question number 17. The modulus of rigidity of water is first option 1, second option infinity, third option 0, fourth option none of the above. We know that the modulus of rigidity of liquid and gases, that is fluid, is always 0 because they are difficult to compress. However, their bulk modulus is very large, close to infinite. Third option is the correct option. The modulus of rigidity of water is 0. Question number 18. If a material is heated and annealed, then its elasticity is first option increased, second option decreased, third option not change, fourth option become 0. When we heated an unyielded material, then its elasticity decreases. So here second option is the correct option. If a material is heated and unyielded, then its elasticity decreased. Question number 19. Out of the following material whose elasticity is independent of temperature? First option copper, second option inwards steel, third option brass, fourth option silver. Here second option is the correct option. The material whose elasticity is independent of temperature is inwards steel. Question number 20. The ratio of shearing stress to the corresponding shearing strain is called first option modulus of rigidity, second option bulk modulus, third option Young's modulus, fourth option none of these. We know that if we take the ratio of shearing stress to the shearing strain, then it is called modulus of rigidity. So here first option is the correct option. The ratio of shearing stress to the corresponding shearing strain is called modulus of rigidity.